Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.
Hello, you are most welcome to AGPS TV, your surest program to academic excellence. Today I have carefully selected a very beautiful topic, Pythagoras Theorem. Why is it beautiful to me? Because this is a topic that even starts from the basic level and move upwards even to the degree level. And so if you know the basics, then simply you will be able to move on and thrive even to the higher level. Now I must emphasize that this theory deals with right angles. The Pythagoras Theorem deals with right angles. Now, when we say right angles, we are simply talking about triangles with one of its sides being equal to 90 degrees. So if you draw any triangle where one of its sides is equal to 90 degrees, then you can say that that triangle is a right angle. And therefore, you can apply the Pythagoras theorem to it. So for example, if I have this triangle, and the triangle, I have one of its sides being 90 degrees. If one of its sides is 90 degrees, and I label it as A, B, and C. If I label it as A, B, and C, and one of the sides is 90 degrees, then we are saying that if you check the AC is going to be the longest side. And Pythagoras theorem is saying that if you square the longest side, the results that you obtain will be equal to the sum of the square of the other two sides. And the other two sides will be BC and AB, or AB and BC. But it says that if you square, so let's write it mathematically. So my AC square will be equal to the square of AB plus the square of BC. That is what the theory says. That if I have a triangle where one of its interior angles measured 90 degrees, then Pythagoras is saying that if that is the case, then all the time it is true that the square of the longest side will be equal to the sum of the square of the other two sides. So for example, let us assume that AC, which is the longest side, is 5. And then the other two sides are 4 and 3 for BC and AB respectively. then we can put this theorem to a test and see if it is true. And so we want to show whether the square of the longer side will be equal to the square of the sum of the other two sides as propounded by Pythagoras. And so our AC in this instance will be 5, as it has been shown. And so we have the 5 square. My AB is 3. So I have 3 square plus finally we have 4 for BC. Now that we have input our figure, we say that the right hand side, the answer should be equal to the left side. As we have shown that the square of the longer side should be equal to the sum of the square of the other two sides. And so when we say 5 square will give us 25. And then the other two sides will be 3 square, that will be 9, plus 16. And 9 plus 16 gives us 25. And that shows that the theorem is true. And so basically we are saying that if you have the square of the longer side, which is AC in this case, it should be equal to the square of the sum of the other two sides. Let's take another example. Let's maintain the same figure but change the measurement to 13, 5, and then we have say 12. So let me put 12 there. So we have this 3. So let me clean here. Once again, because it is a right angle, we can have our AC to be 13, our AB to be 12, and our BC to be 5. And so my AC here is 13, so I have my 13 square, plus my AB, which is 12 square, plus my BC, which is 5 square. Now from here you realize that 13 square gives 169. So we have 169. It means that if I also square the 12 and then the 5, it should give, and I put them together, it should give me 169. And so we have 12 square, and that gives 144. And then we have 5 square, that also gives 25. And then when you do your calculation, you discover that 144 plus 25 gives 169. And so that is how you can apply it. The second thing that I want to show you is that Pythagoras theorem does not only show that if you have the square of the longest side, it's going to give you the square of the other two if you sum it up. But it also shows that if you have a right angle and then you have two sides, you can use the two sides to find a third side. If you have two sides, you can use the two sides to find the third side. So let's go back to the first example. Let's go back to the first example. This time around, I'm having my longer side to be 5, and then my BC is 4. So now, if you remember, the first example, AC was 5, BC was 4, and then my AB is 3. But I have removed the AB. But this theorem is saying that if it is a right angle, and then you have two sides, you can use these two sides to locate a third side. But we have discovered that the square of the longest side, which is AC square, should be equal to AB square plus BC square. So we can simply do this by substitution, or you can make your AB the subject. But I want to simply, for the sake of those who are in the basic level, I just want to maintain it like this and do substitutions. And so for my AC square, I'll have 5 squared, and it will be the same as my AB. I don't have it, so I want to repeat it. I don't have AB square, so I maintain it there, plus my BC, and my BC is 4. So I have 4 squared. Now here is 5 square, and 5 square was seen to be 25. And then I have my AB, so I maintain it. And then my 4 square is 16. So from here, I can group like terms, or I can maintain or make my AB the subject. So I transpose my 16 here. That is going to give me AB square equals to 25 minus 16. That is if I decide to rearrange it. And so 25 minus 16 gives me 9. So I have my AB square gives 9. Then finally, because I want my AB and not AB square, I find the square root of both sides. And so I find the square root of AB and then the square root of AB. The square root will nullify the square root, and so I have my length of AB. And then we know that the root of 9 is 3. And so finally, we arrive at our 3. And so it is also true that when you have two sides of a right angle, you can apply the principles of Pythagoras Theorem to look for the third side. Let's take another example with that example 2. This time around, I'm also going to, this time around, the 13 will maintain. Then this side, I am going to remove it, and then I write my 12 here. But if you remember, this side was 5, the BC. And so we want to show if you can find it. You want to show if you can use the same principle to find the 5. And so from there, we go and then we write the principle down. So we have our so we have that. So from there, we write our 13, which is for AC. And then our AB is 12. And then our BC, we don't know, so we maintain it. Then from here we can simplify them. Our 13 square has been seen to be 169. And then our 12 square is 144. And we are adding it to our BC square. Then we can also group like terms. Let me put my 13 there so that it doesn't confuse you. So I bring my 144 here, so I have 169 minus 144, and my answer is equals to BC square. If I rearrange it, I'm going to have my BC square, and then 169 minus 144 gives me 25. If I want to find the square roots of both sides to get my BC, so my square will cancel that, so I have my BC, and then the square root of 25 is equals to 5. So you realize that you can use 2 of the sides to locate or find the third size. Let's take more practical or more example of such. Let us assume that we have triangle PQR, and then our PQ is 13 centimeters. Our PN, which is the height, is 12 centimeters, and then our PR is also 15. And then we assume that these are right angles. These are right angles. So we assume that. So if these are right angles, then they can ask you a question to find QR. They can ask us to find the length of QR. So to find QR, you can say that QR will be equal to the length of QN plus the length of NR. So if you want your QR, if they ask you to find QR, then know that it will be QN plus NR. That will give you your QR. But from here, you know that since you have 2 sides, then you can use Pythagoras Theorem, where your longer side will be your PR. So we say that from here, your PR square will be equal to your NR square plus your PN square. So if you're able to do that, you can use that to find your NR as you have demonstrated. So from here, your PR is 15. We don't know our NR, so we maintain it. And then our PN is 12. So we have 12 square. And so from here, our 15 square gives me 225. And then since I don't have my NR, I maintain it. And then my 12 square is 144. So I have that. So I can find my NR. If I rearrange it, I have my so I have 225 minus 144. And so I'm going to do my subtraction. So I have my NR squared to be, this is 1, and this is 8. So I have 81. Now if I want my NR, I simply find the root of that. And then the root of 81 simply gives me 9 centimeters. So we know that our NR is 9 centimeters. Our NR is 9 centimeters. So we see that we have applied the same, we're using the two sides to calculate for the third side. And so we can also similarly use the same principle to calculate for NR by using our PQ and then our PN. So let us do that. So from here, our PQ will be the longer side. That will be equal to our QN plus our PN. Because we are calculating for our QN, as it was seen, we know that our PQ from the diagram was 13. Equals to, we don't have our QN. Since we don't have our QN, we just maintain it. And then we have our PN to be 15. So we are, sorry, our PN was 12. Our PN was 12. So we have our 12 square. So from here we have our 13 square. That gives 169. Then we have our QN square. And then our 12 square is 144. If you rearrange it, we are going to have our QN square. That will be equal to 169 minus 144. So finally, my QN square will be equal to 169 minus 144 gives me 25. And so if I find the square root of both sides, my QN finally gives me 5 centimeters. And so I have that. So I have my NR to be 9 centimeters, and then I also have my QN to be 5 centimeters. But you have indicated that your, as it were, your QR is equal to your QN plus your NR. Therefore, from here, you discover that we have our QR equals to QN, and our QN is 5 centimeters, and our NR is 9 centimeters. Therefore, my QR will be equal to 14 centimeters. And so you can apply this rule or this principle or this theorem to find the third side when you have two sides. Let's take the final example and then we close for the day. We take the final example. I hope you are finding this lesson helpful. Let's consider this diagram too. Why we have triangle ABC with a height of AD, and then we are asked to find say BD. We are asked to find say PD. This was similar to the ones that we've done, and because this is ADC is a right angle and you have two sides, AC and AD, you can find your DC, and similarly you can find your BD. But again, you know that your BC will be BD plus CD or DC. So you can apply that. And so from here, let us use the same way we did with the first, just to emphasize the point I was making. So from here, my AC square will be equal to my AD square plus my DC square. So I have my AC to be 15, then my AD is 12, and I do not have my DC, so I have my DC. Because I want to find DC, I make it a subject. So I group like times, so I have my 225 is equals to 144 plus DC square. And so I'm having so this is what I'm having. So once again I subtract. So I have my 225 minus my 144 as shown in the previous example was 81 equals to my DC square. So if I want to find DC, I only find the root of that, so that my DC will be equal to 9 centimeters. Then we have shown, if you solve the similar one as we have shown, then you are going to get 5 centimeters. And so when you add 8 to this, then finally you get 14. It's just like the other one that we did. And so I'm leaving this one for you to complete it, and then you add it to this. Again, I am going to ask you to determine whether or not this is a right angle triangle. So when you go, then you go and try it. I'm going to leave this thing to you for you to try it and then find out. So you complete this one, then you try the next one. If you have challenge, you can come and then you put it on the comment column whilst I try to help you solve it. So we have a diagram like this, where your AB is 12 centimeters. Then you have your BC. Let me make your BC. Okay, let's maintain the BC. Then we have our AC, and then we have our CD, and then we are asked to find AD. You are asked to find AD. So let me make this one. Let me make this one 5. Let me make that one 5 centimeters. Let me make it 5 centimeters so that we have 5, and then we have that. So you go and try this one, and then you show whether you can apply that. If this is a right angle and that is also a right angle. So let us see if you'll be able to try this. Any challenge that you get, draw my attention, and then we are going to discuss it in my future tutorials. My name is Mr. Samsinane. This is AGPS TV. You can like and share the page. If you have also any interesting topic that you want us to address or treat, you can send it through the comment column, and then we come on your way and treat that topic, and then we see our best we'll be able to help you. Stay blessed and stay safe. My name once again is Mr. Nane, and this is AGPS TV. Stay blessed and see you next time.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.